Okay, it's complex number skills time. We are talking about polynomial functions and their zeros, and sometimes those zeros happens to be imaginary or complex. So let's first talk about the difference between the words imaginary and complex, because a lot of times they're used interchangeably and it might not necessarily be correct. So a complex number, every number you've ever heard is complex. When you heard the number 4, 4 is complex because it's 4 plus 0i. All complex numbers, which is all numbers, have a real part and an imaginary part. And before you learned about I and all that, all the numbers you knew were just that number plus 0i. So complex number is any number. The imaginary part may or may not be 0. By the way, it could be 0 plus 2i. So that's a complex number also, 2i. And so we'll get our terminology down. I, by the way, which you should know hopefully at this point, is the square root of -1. So as I understand it, mathematicians, developed all the math that you're learning, and then they never could take the square root of a negative, so they would try to solve an equation like a quadratic and get a negative under the square root, and just stop and say no solutions. Well, sort of inventing or just making up, well, let's just make up a number. It's the square root of -1. That allows us to find solutions to equations, find the values that make them true when there are no otherwise real numbers that make them true. So that's kind of where i's came from. So when we're going to be working with these polynomials, we need to be able to work with i's. So let's start with powers of I. I to the first equals I, because anything to the first equals itself. I squared is -1. If I is the square root of -1, then squaring it gives you -1. I cubed, 2 of those i's become a -1, and the other one is just left, so we get -I, right? I times I is -1, and then there's a third I. And then I to the fourth equals 1, because 2 of them become a -1, 2 of them become another -1. Those two -1s multiply to give you +1. So you can find any power of I by kind of going back to this pattern. I to the 81st. What you can do is take out 4 i's at a time. I've got 81 i's being multiplied together. Every time I see 4 of them, that's equal to a 1. Since 4 goes into 81 times, 80, what would that be, 20 times, with 1 left over, I'd have 20 I to the fourths, each of which are equal to a 1, and then just 1 I left over. So I to the 81 equals I to the 1, which equals I. Okay, so you can do any power like that. If I had I to the 82, that would be equal to I squared, which would be -1. I to the 83, 80 of those i's just vanish, so I can take out 4 at a time. So basically divide 83 by 4 and leave the remainder. So I to the 83rd is -I. So by that little pattern, you can get any power of I that you want. 1 over I to the 83, by the way, would be 1 over I to the 3, which would be 1 over -I. Now, that brings us to our next topic of add, subtract, multiply, and divide. You cannot have i's in the denominator, much like you cannot have square roots in the denominator. So what do we do with 1 over -I? We need to rationalize it like we would rationalize a square root in the denominator. Multiply it by I over I. That gives me I on top and -I squared on the bottom. But -I squared is -1, which is +1. So we get I over 1. So keep that in mind when we get to this dividing down here in just a minute. All right, so we need to add, subtract, multiply, and divide 2 complex numbers. So I'm going to start with these 2 complex numbers, and we'll just use them to do each of these 4 examples. So let's add them. When you add complex numbers, it's just like adding polynomials. If I were to add -1 plus 3x plus 2 minus 4x, I would add the x parts, and I would add the constants, and I would get, what's that, 1 minus x, I think. All right, that's going to be how we add and subtract complex numbers. So I have -1 plus 2. These two go together. That gives me a 1. And I have 3 minus 4i, which is -i. So the sum of my two complex numbers is 1 minus I. What about subtraction? Same deal, just like polynomials. In this case, the only difference is this negative distributes to both parts. And I have -1 minus 2 is -3. And I have 3i minus -4i, 7i. Okay, so there's adding and subtracting. Nothing too difficult there, just like terms, basically. It has an I or it doesn't. Multiplying. All right, so let's multiply the two complex. -1 plus 3i, 2 minus 4i. And this, most of you probably were taught to FOIL something like this, two binomials, which basically means distribute twice. Distribute the -1, distribute the 3i, and call it FOIL if you want. All right, so -1 times 2, -2. -1 times -4i, plus 4i. 3i times 2, 6i. 3i times -4i, -12i squared. So here's a little quick way to think about it. Anytime you see an I squared, you can take it out and put in a negative sign, right? Because I squared is -1. So what's going to happen when you FOIL a couple of these, I'll go ahead and put the two like terms in the middle together. And then I get -12 times -1, which basically just takes that from a -12 to a +12. -2 plus 12 is 10 plus 10i. And usually we write complex numbers in a plus bi form. So 10 plus 10i, I'm writing all these answers, and it's real part plus imaginary part. All right, so there's multiplying. A little bit more involved than adding and subtracting, but not too bad yet. All right, just remember, an I squared is the same as a -1. Think about this question. Is if I multiplied those two numbers in the other order, would I get the same answer? Think about that for the other two. Adding and subtracting and multiplying. Does the order matter? Does the order matter for division? Think about those. Ask in class if you're interested. -1 plus 3i. The answer, by the way, is for some of them it does and some of them it does not. Think about how you rationalize the denominator if it had a square root in it. If you had a denominator of 1 plus the square root of 2, we got rid of that by multiplying by 1 minus the square root of 2. Because when you FOIL that, the O and the I terms go away. That's what's good about multiplying something by its conjugate. You get rid of those middle two terms. And look where we multiplied just a minute ago. The middle two terms are the only ones that have i's in them. The other two terms don't have i's in them, so therefore we're not going to have any i's in the denominator. So let's multiply by the conjugate, top and bottom. Remember, a conjugate is not the negative of it. It's the imaginary part is subtracted and added. The 2 stays the same. Okay, so on the top, we're going to have to FOIL. -1 times 2. Wait, I know what that is. No, I didn't. I did that with a minus earlier. So -1 times 2 is -2. -1 times 4i minus 4i plus 6i plus 12i squared. On the bottom, 2 times 2 is 4 plus 8i minus 8i. There's where my O and my I terms. When I say O and I mean outer and inner. this, and this. Those are always going to cancel with conjugates. Those are going to go away, and then I have minus 16 I squared. So let's clean that up a little bit, put it into a plus bi form, and see how it looks. We have on top a negative 2 and a 12i squared. Remember, 12i squared is the same as negative 12. So negative 2 minus 12 is negative 14, plus 2i from my minus 4i plus 6i. The denominator, I have 4 minus 16i squared. Those are gone. Minus 16i squared is the same as plus 16. So I get 4 plus 16 is 20. And since 2 goes into all of those, I can do negative 7 plus I over 10. A common mistake would be, let me cancel those and make that a 7 and a 10, but leave the 2. If you're going to divide, you're going to divide everything by 2. Don't leave out any parts. So negative 7 plus I over 10, that would be really just fine, but to keep the pattern going of a plus bi, negative 7/10 plus 1/10 I. Just in case the question asks for it to be in that form. All right, so like I said, we're going to be working with some polynomials that have some imaginary parts to their roots, some complex roots. So you have to be able to work with i's, and that's what this day is about. Just some skills based on complex numbers. You need to be able to find powers of I. You need to be able to add, subtract, multiply, and divide complex. So I am out.